So today we're going to be talking about piecewise functions. Feel free to pause this video wherever you feel necessary. Piecewise functions. Functions represented by at least two equations that correspond to different domains. Evaluating piecewise functions. Choose which equation to use based on the x value in the corresponding domain, and then substitute in the values and evaluate following order of operations. So let's look at our first example here. Evaluate the function of the following values of x. So we can see here what a piecewise function does is it separates a graph into two different functions. So we are only going to care about this equation when x is between -2 and 0 or is equal to -2 and 0, as you see here. We're only going to care about this equation right here is when x is greater than 0, not equal to, but just greater than 0, or less than or equal to 4. So let's look at our examples here. X equals 0. Which domain does that fall under? That falls under this domain right here, because we can see that 0 is included in this domain, while 0 is not included in this domain here. So since this is the domain that we are looking at, this is the equation that we are going to substitute 0 into. So our answer for this is, if we were to put 0 in, we would get 3 times 0 plus 2. We know this would give us 3. This would give us 0. 3 times 0 is 0, plus 2 is going to give us 2 as our final answer. Now you can see here we have x is equal to 3. 3 is within this domain that we have right here. So this is the equation that we're going to care about. When we put 3 in for x, we get 3 minus 1, which gives us 2 as our final answer. Now, let's look at this 6 that we have right here. 6 does not fall within this domain because it is not between -2 and 0. It also does not fall within this domain because this is just between 0 and 4. So the answer would be not in domain. Now let's talk about graphing a piecewise function. Graphing piecewise functions. Step 1. Divide the graph into parts of the domain by drawing a vertical highlight at the change values. Step 2. Substitute in the change values of the domain into each equation. Prepare xy for each point. Graph these points. Use open and closed circles appropriately. We know when we have something that is not equal to, it is open, and when we have something that is equal to, it is closed. Step 3. Substitute in other values within each domain to graph or graph the equations within its domain only. Now let's look at our first graph. So the first thing we're going to want to do is highlight where things change. So things are going to change. You see here, if we look, things are changing at x is 3. All right, it changes equations where x is 3. So we're going to highlight at x is 3 right here. Now, this is saying when x is less than or equal to 3, we care about this equation right here. When x is greater than or equal to 3, we care about this equation right here. So first, let's graph this equation. This equation has a y-intercept of -2, and then we go up 2 over 3, up 2 over 3. This is our line for this equation. Now, just like we said before, we only care about this equation when x is less than or equal to 3. So we only care about this equation from here over. So what we're going to do is we're going to make this a closed circle because it says that it's equal to 3, and we are going to erase everything. I hope you're writing in pencil because there's going to be a lot of erasing. So now, the next part of this, when x is greater than 3, we are going to care about this equation right here. So let's graph this equation. We know that it crosses the y-axis at 1, and it has a negative slope. So if we go up 1, left 3, up 1, left 1 is what I meant to say, up 1, left 1, down 1, right 1, we're going to have a line that looks something like this. But we only care about this line when x is greater than 3, which means there's an open circle here, and we don't care about any of this because we only care where it's greater than 3. So all of this can be erased. And this is what we are left with as our piecewise function. Now let's look at our next problem. The first thing we're going to want to do is highlight where things are changing. So we can see that our first interval right here is from -4 to -2. So let's highlight -4, 2, 3, 4, and -2. We can see that our next interval is from -2 to 0. We already have -2 highlighted, so let's highlight 0. Our next interval is from 0 to 2. We already have 0 highlighted, so now we highlight 2. And our last interval is from 2 to 4. 2 is already highlighted, so now we highlight. So now, between -4 and -2, we are graphing the line y equals 1. Remember, when y equals a number by itself is a horizontal line. All right, so when y just equals 1, all it is a horizontal line. So between -4 and -2, we are going to graph the line y equals 1. We can see here that it's equal to at -4 and not equal to at -2. Now we are going to graph the line y equals 2 between -2 and 0, our next interval right here. Our line is going to be y equals 2, which will be graphed here. We see that it's equal to -2 and not equal to 0. So we have an open circle. Next, we're going to graph the line y equals 3 between 0 and 2, which is right here. This is 0, here's 2. We are graphing the line y equals 3. We can see that it's equal to at 0, not equal to at 2. Lastly, we are graphing the line y equals 4 between 2 and 4. An open circle at 4 because it's not equal to, a closed circle at 2. And this is our piecewise function graph. Now let's look at our next graph. Again, we're going to want to highlight where things are changing. So you can see here that things are changing at x equals -1. So we highlight -1. We see here that things are changing at -1 and 2. -1 is already highlighted, so now we must highlight 2. And then we see here that when x is greater than 2, things are changing again. We already have 2 highlighted. So what this function is saying here is that we only care about this equation right here when x is less than -1. So let's graph this line. Warning, we're going to be doing some erasing. We can see that the y-intercept is at -1, and we have a slope of -2. So first, let's graph our y-intercept at -1, which is right here. We have a slope of -2, so we can go up 2, left 1, up 2, left 1, or we can go down 2, right 1 from original, and we have this line right here. Now, we only care about this line when x is strictly less than 1 and not equal to, which means we're going to have, I'm going to erase, an open circle here, and we don't care about any of this. We only care about when x is less than negative 1. Now let's look at the next interval. We are going to graph the line y equals 1 between negative 1 and 2. This is the line y equals 1. It is equal at negative 1, so while we had an open circle before, now we are shading it closed. That is a mistake I see people make all the time. For some reason, when there's supposed to be an open circle and a closed circle in the same spot, oftentimes I'll see students go like that or something like that, and that is incorrect. When there is an open and a closed circle in the same spot, the closed circle wins every time. Don't make that mistake. At x equals 2, we have an open circle because it's not equal to. This is a big mistake. Don't make it. When there's an open and a closed circle on the same spot, closed circle wins. And lastly, we are going to graph this function right here when x is greater than or equal to 2. So this is a quadratic function. So at x equals 2, if we were to put 2 into this, 2 minus 2 is 0. 0 squared is 0. So since it is equal to 2, we will have a closed circle here. When we put 3 in, 3 minus 2 is 1. 1 squared is 1, so we're going to have a point here. When we put 4 in, 4 minus 2 is 2. 2 squared is 4, so we have a value here at 4, and now we can draw our equation. Now let's go on to the next one. So now you can see with this function here, again, we're going to want to start highlighting where things change. Things are changing at x equals negative 2, so we highlight negative 2. Things are changing at negative 2 and 1. Negative 2 is already highlighted, so now we highlight 1. Things are changing at 1, which we already have highlighted, so we don't have to highlight again. Now, when x is less than negative 2, we are going to care about this equation right here. So let's graph this equation. We have a y-intercept of negative 2 and a slope of negative 1/2. So if we go up 1, left 2, up 1, left 2, we're going to have a line that looks like this. So now we only care about this line when x is less than or equal to 2. So there's a closed circle here, and we care about this from here over. So now we can erase this. Now let's graph our next interval. We are going to graph the line y is equal to x between negative 2 and 1. The line y is equal to x has a y-intercept of 0 and a positive slope of 1. So here is our line y is equal to x. We only care about this line between negative 2 and 1. It is not equal to negative 2 or 1, so make sure you have an open circle here. Alright, there should be 2 open circles because it is not equal to. After that, we don't care about anything else besides between negative 2 and 1. And now for our last bit of our piecewise function. We graph the line y is equal to 2 when x is greater than or equal to 1. Here's the line y is equal to 2. We only care about this when x is greater than or equal to 1, which is here. So we have a closed circle because it is equal to, and we don't care about any of this. Now let's go on to our last one. Shipping costs $6 on purchases up to $50, $8 on purchases over $50 and up to $100, and 10 on purchases over $100 and up to $200. Write and graph a function for the cost of shipping. We're going to make our y-axis cost of shipping. And we're going to make our x-axis cost of purchase. For scaling, we're going to label each of these as 10. I'm going to go up by 50 though. So 1, 2, 3, 4. So 50 is here. 60, 70, 80, 90, 100. 110, 120, 130, 140, 150. 160, 170, 180, 190, 200. That's all we need to label for the purposes of this graph. We know this is 0. So now, we know that the cost of shipping, we'll label these by 1, would be $1, $2, $3, $4, $5, $6, $7, $8, $9, or $10. So it says here, shipping costs $6 on purchases up to $50. So you're never going to have a 0, because if you purchase $0 worth of merchandise, you didn't purchase anything, and I hope you're not paying shipping for absolutely no reason. So they're going to have an open circle here because it doesn't make sense to have a closed circle at equaling $0 because you're not buying anything. It costs $6 up until $50, where it will have a closed circle because it's up until $50. Now, $8 on purchases over 50 and up to 100, which means it's going to cost $8, not including 50, but over 50 until 100, shipping will cost $8. And at $10 on purchases over 100 and up until 200. So from 100, anything over 100 will start costing $10 until 200, shipping will cost $10. This is the graph that you should have had. The rest of this practice I want you completing on your own and showing to me during our next class.